So now I'm going to be going over functions, mappings. This is pretty much a basic introduction. So before defining what a function is, let's first understand how numbers can be connected. You can think of this as this rule or equation as a machine. Okay, this is our machine. So you put a number in, our input, and we're going to get a number out, the output. And the way inputs are connected to outputs is called a mapping. All right, so there are three main types of mappings. The first one is a one-to-one mapping. Okay, so in a one-to-one mapping, each input, okay, let me just draw that out. This is inputs, these are outputs. So these are inputs, these are outputs. So each input gives exactly one output. So it's going to be connected something like that. So for example, y equals to 2x plus 1, where y is the output and x is the input. All right, it's important to remember that. So for whatever inputs we have, which means for every single value of x, whether it's -2, -1, 0, 1, 2, all the way up until infinity or even negative infinity, you'll only get one answer, only one value of y. So for example, if we have y equals to, let's say when the input is -2, 2 times -2 plus 1 will give us -4 plus 1, which will give us -3. All right, so that's for one-to-one mappings. Next up, we have many-to-one mappings. One mappings. So in many-to-one mappings, different inputs can give the same output. So let's draw that here. This is our inputs. This is our outputs. So different inputs can give you the same output. All right. And let's take the example y equals to x squared, where again, y is the output, x is the input. So if x is equal to 2, all right, y is equal to 2 squared, gives us 4. And if x is equal to -2, y is equal to -2 squared, which also gives us 4. So this shows that we have two outputs. We have one output, 4, with two inputs, 2 and -2. Now the final kind of mapping, the third kind of mapping is a one-to-many mapping. Many mapping. So basically in this kind of mapping, all right, again, inputs, outputs. One input gives more than one output. Let me show you an example. Let's take the equation y equals to plus minus the square root of x. So if x is equal to 4, all right, we have one input. Our y is going to be equal to plus minus 2, positive 2 or negative 2. So we have two outputs. This kind of mapping is not allowed when we talk about functions, but more on that later. So now that we understand mappings and the basic kinds of mappings, we can define a function. So simply put, a function is a special kind of mapping where each input gives exactly one output. And the most important part here is the one output. This is the most important thing you have to remember when talking about functions. So this means that one-to-one mappings are considered functions. One input, one output. Many-to-one functions are also considered functions. Why? Because even though they have many inputs, over here they have only one output. And that's the most important thing that matters. Finally, we have one-to-many mappings, which are not functions because they have one input, but they have more than one output. So usually two outputs. And this is why it's not considered a function. Now, functions are usually written in the form f of x equals to y. All right, this is the most common form that it's presented in. And in this case, like I explained before, x is the input and y is the output. All right, x over here, input, y is the output. So the letter f over here, that's just the name of the function. It can also be g of x, h of x, or any other letter, all right? It's just a name. And a very important point to note is that this f of x does not mean f multiplied by x. What it means is the output that we get, the f of x that we get when the input is x. For example, if you have f of x equals to 2x minus 1, and let's say our first input is 3. For input is 3, that means x is equal to 3. X is our input. So f of x equals to 2 times 3 minus 1. 6 minus 1 gives us 5. And when our input is negative 2, when x is equal to negative 2, f of negative 2 equals to 2 times negative 2 minus 1. Negative 4 minus 1 gives us negative 5. All right? So this is an example of a function. Now let's look at domain and range. The domain of a function, simply put, is all the possible inputs, and the range of a function is all the possible outputs. So inputs are the same as x values, as I said earlier. So we can also say the domain is all the possible x values, and the range is all the possible y values. All right, this is very important. Now, to kind of understand domain and range, let's draw a table of values. Here, let's think about the function f of x equals to x squared. All right. So to draw, we have x and y, but since it's a function, we don't use y, we use f of x. And you may be wondering, why do we use f of x and not y? It doesn't matter. We usually use f of x, but remember, f of x is equal to y, so it does not make any difference at all. So we have f of x, of y, and then let's draw our table of values. Let's draw a couple of boxes, and let's plot a couple of values. So when the input is, let's say, negative 2, negative 1, 0, 1, 2, these are just any random values I chose. And to find the value of y, or the f of x, all we have to do is, see this equation over here? F of x equals to x squared. All we have to do is substitute the value. So f of x, our first f of x, is equal to negative 2 squared. We substitute the negative 2, and we're going to get 4. So you substitute all the values, and you're going to get something like this, 4, 1, 0, 1, 4. Okay, now looking at this table of values, let's try and deduce the domain and range. So the domain is all the inputs. So as you can see, the inputs, they are positive inputs, negative inputs, there's even 0. So it's safe to say that all the inputs are considered functions. I mean, all the inputs can be accepted into the functions. So the domain is, we use the symbol for real numbers, which is every single number that exists. So the domain is all real numbers. Now, as for the range, we can see that it decreases from 4 to 0 and then increases again. So the lowest y value that we get, the lowest f of x, is 0. The range is always equal to 0 or larger to 0. So we write y is greater than or equal to 0. All right, so we're going to represent the values. Now, an easy way to visualize this is by drawing a graph. So here our function is f of x equals to x squared. And if we were to draw it out, this is going to be our x plane. This is going to be our y plane. We're going to get a curve like that. Okay, it's going to be even. Sorry, my drawing is a little off. So this is going to be our curve, and you can see that the inputs, all the x values, they increase until infinity in both directions, slowly increasing. So you can see that the domain is all real numbers. The range is just all the y values. You can see that 0 is the lowest point. So again, it's the same thing. Y is greater than or equal to 0. So just by looking at this, we can tell the domain and range of a function by drawing out the graph. So the domain is all the x values, which is this horizontal plane, and the range is all the y values, which is this vertical plane. Next, let's look at something called domain restrictions. Sometimes the rule of a function restricts which values of x are allowed. Let me give you two examples. The first one is when we have a square root. So let's say f of x equals to the square root of x minus 1. Now, as you know, a square root can never have a negative number. This x minus 1 within the square root has to always be greater than or equal to 0. It can be 0, but it can never be less than 0. We move the negative 1 to the other side, so negative 1 becomes positive 1. So x is always greater than or equal to 1. So this is the restriction of the domain for this function. The domain, all the values that we get, all the outputs, will always be either 1 or any number that is greater than 1. Now, the second example that I'm going to show you is for fractions. So let's take f of x equals to maybe something like 1 over x minus 2. So you should know that division by 0 is not allowed. We can never have 1 over 0. It simply doesn't work out. So this x minus 2 can never be equal to 0. So this means we move the negative to the other side. So x can never be equal to 2. All right. So this value must be excluded from the domain. Now, let's say you have a graph. All right. This is y, this is x. And you may be wondering, how do I know if a graph is a function or not just by looking at it? We have something called the vertical line test. Basically, if any vertical line cuts the graph more than once, then the graph does not represent a function. So, for example, if we have the same one as before, y equals to x squared, this is our parabola. And if we were to draw a vertical line anywhere along the graph, so if we were to draw it here, 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 or here, it only intersects with the graph once. Okay, this is an example of a function. However, if it's not a function, let's say x equals to y squared, we're going to get a horizontal parabola. So we're going to get something like, let me change my color. We're going to get something like this. So if we were to draw a vertical line, you can see that there are points, there are places on the graph where pretty much there are two intersections. So it's not a function, all right, because there are two intersections. So this is the basic idea behind functions. This understanding forms the foundation for everything else in Add Maths, including inverse functions, composite functions, and transformations, which we're going to cover on later.